IPv6 subnetting. Subnetting means dividing an IP address space into a hierarchy of subnets of different sizes, making it possible to create subnets with very different host counts without wasting large numbers of addresses. The main challenge with subnetting is assigning subnets that provide sufficient host addresses per segment, and at the same time not having too many unused addresses left over. Benefits of subnetting. Number one, it reduces the total number of routes and routing table entries that routers in the network must learn and keep state information on. Number two, it can reduce the administrative overhead associated with tracking address assignments. Number three, it can help create well-defined network and administrative boundaries that allow us to simplify security policy and improve operations performance. The first type of subnetting is nipple subnetting. A nipple is 4 bits within 1 hexbit. Actually, this type of subnetting has several important benefits for address planning. According to CIDR notation, for any prefix we will use always a multiple of 4. For example, here /64, then /60, then /56, /54, /48, /44, etc. And here we can see an example of IPv6 with the global router, global routing prefix length 48 bits. As we get into our address plan design based on the network topology, it is common to have any network entities like VLANs, buildings, business units into the subnets. For each subnet, we will assign an ID, and the bits used to assign the subnet ID are allocated from the first part of the IPv6 address, which is the global routable prefix. Therefore, the structure of IPv6 will be like that, and this is the typical structure: 48 bits for the prefix and 16 bits for the subnet ID, and the interface ID is fixed with 64 bits. Now, IANA is divided the global routable prefix part of the IPv6 address into several parts. First, 3 bits for global unicast, and IANA now is distributing only the binary value, which is 001, that is equal to 2 in hex. The second part is 12 bits. This is for the regional internet registry. For example, the RIPE NCC now takes 2A00:/12, and the other RIR takes different value. Then /32 bits. This is for the ISP, which is according to RIPE NCC. This is the minimum assignment, as we will see. Now the fourth part is /48 bits for a customer within a country, like for example ministry, university, public organization, etc. A customer can get /56, for example, but this will minimum his available addresses space. If a customer decide to get /48, then the subnet ID will be 128 bits minus 64 bits for the interface ID and minus 48 bits for the global routable prefix. So this will equal only 16 bits, and the 16 bit will provide 2 to the power 16, which equal 65,536 subnets, which is sufficient for any number of enterprise. And if another customer decide to get a /56 for the global routable prefix, then the subnet ID will be only 8 bits, and that will provide 2 to the power 2, which is 256 subnets only. Here in this slide, the ideal situation shows that the customer is taking 48 bits for the global routable prefix, which means the total number of customer subnets will be 65,536 subnets, which is, as we said, a sufficient number for even future expansion. This is this table from the RIPE NCC assignment policy. Currently, most ISP assign /48 network prefix to their subscribers, because all IPv6 network have 64 prefix. /48 network prefix allows 65,536 subnets within the customer site. The current minimum IPv6 allocation made by the RIPE NCC is /32 network prefix. Okay, and we can see here there are different options for allocation. You can get the /128, which is one IPv6 address, and you can get also a /64, which is one subnet, and you will have plenty IP addresses. And you can get /64 or /56 and /48, and the minimum is /32. Let us get back to the usual IPv6 structure to explain how the subnets will be numbered. The typical structure is 48 bits for the prefix and 16 bits for the subnet ID and 64 bits for the interface ID. Suppose that we get this routable prefix 2001:db8:11AA:/64 from the provider. The total number will be, the segments within our site will be numbered like that: 2001:db8:11AA:. This is the ID for the first subnet, which is 0000. Then the second subnet will be assigned 0001, 0003 for the third subnet, then all the way to to FFFF subnet ID, and the total number is or total number of subnet is 65,536 subnets.